Hi, my name's Rich Boren, the owner of Cruiser Services, and in an ongoing series of Schenker Watermaker tech classes, we like to take a Watermaker technical topic that I've been getting questions on either recently or over the years and break it down into a simplified discussion so that you can understand what's going on with your Watermaker. We've learned over the years that some of our best clients in terms of having success in operating their water maker is to understand it. The clients that know what's going on, who understand some little technical basis that really helps you maintain and use your water maker properly so that you have the least amount of problems. Now, this topic is something that I get asked all the time, and the question is basically, why when I start with my water maker, is the product water always salty for the first 30 seconds to 60 seconds? Why is that? Because if salt doesn't get through the RO membrane, why is that startup water salty when I start my unit up? I freshwater flushed it when I shut it down. So why is that initial product water salty? It's the same for all water makers. It's the same for all reverse osmosis systems, whether it's a Marine Watermaker or not. So let's talk about this subject and see if we can answer some questions as to why this is the case. Now, in order to understand this, we need to talk about reverse osmosis and osmotic pressure in general. So what is osmotic pressure? Just to define a term a little bit to help us. You can roughly think of osmotic pressure as a measure of the salt content. The higher the salt content of a water stream, the higher the osmotic pressure. So fresh water has very low osmotic pressure. Concentrated seawater, which is about 32,000 parts per million, has a much higher osmotic pressure. So that'll come into play here when we talk about why salt particles, or not particles, but molecules, ions, why they're moving through the membrane when your water maker is off. So let's look at a container of water, and in that container of seawater, you have a membrane going down the center, which is our reverse osmosis membrane. Now, you have seawater sitting at 32,000 parts per million on each side. So your volume is the same and your concentration of salt molecules is the same. Now, if you apply 600 psi of pressure, which is about the osmotic pressure of seawater, what it takes water molecules to travel through the membrane, because water and salt molecules, the natural laws of physics and osmotic pressure want the concentrations to be the same on either side of the membrane. So if you put 600 psi on one side, you're applying a force. That's going to overcome the osmotic pressure, and water is going to move from the side of force to the non-force side and make that other side of the membrane more diluted, less concentrated. Well, that goes against the basic laws of osmotic pressure, which says water molecules want to move across that membrane to have an equal concentration. So that's where the word reverse osmosis comes in. You're reversing the osmotic pressure of a liquid and making water molecules move through a membrane into the less concentrated side, because it doesn't want to be less concentrated, more concentrated. It wants to have equilibrium across that membrane. So to make it go against the natural laws of physics, you need to apply pressure. Okay, well, you've made water, you've turned your water maker off, and now you have product water on one side of the membrane of about 150 parts per million. The other side is seawater, and it's probably up to 40,000 ppm now because you removed water from it. Normally it's 32,000, but the force you applied probably bumped that seawater side up to 40. So you got 40,000 parts per million on one side, 150 to 200 on the product water side. You now have a concentration gradient. So at first, and this is important because it's a time issue here on when things happen, water molecules want to move from the product water side to the more concentrated seawater side because the natural forces want to equalize. So at first, that's what happens. You turn your water maker off. The product water left on the product water side wants to be pulled through the membrane to equalize that concentration balance. Well, an RO membrane rejects about 99.6 to 99.7% of salt. But some salt can still get through the membrane. So while your water maker is sitting off, salt molecules, dissolved ions of sodium and chloride mainly, move through the membrane. You have water wanting to go this way, salt molecules going that way from a high to low concentration. As that concentration equalizes, you'll then get a higher salt concentration on your product water side. It doesn't happen immediately, but it takes time. 12 hours, overnight, 24 hours. So the longer your water maker sits in the off position, the higher that concentration of salt ions on your product water side is going to be. So one question I get when I give this explanation to people is, well, wait a second, Rich, I freshwater flushed my water maker before I shut it down, or as I was shutting it down, because I know good water maker maintenance says to not leave a bunch of seawater sitting in your unit. Well, that's true. You did a freshwater flush, so you took that 40,000 ppm, maybe down to 10, maybe down to 5,000 ppm, but you didn't take it down to 150, because if you did, you'd probably have to freshwater flush your water maker for 10 minutes, 15 minutes. Not only is there not a need for that, most people don't want to waste that much fresh product water in freshwater flushing. So people freshwater flush for 1 minute to 3 minutes, maybe 5 minutes. So they've taken the seawater side concentration from, let's say, 35, 40,000 ppm down to maybe 10, maybe 5 at the lowest. So you still have a concentration gradient between this product water side and the seawater side. So the longer that water maker sits off, more of those salt molecules are slowly going to migrate through the membrane, and they want to equalize themselves. And without pressure driving the fresh water through the system, they will equalize. So that's why your first 30-second to 1 minute, maybe a minute and a half of product water production has that saltier taste. Not quite seawater, but it still has that saltier taste, certainly above the 500 parts per million upper limit we like to use for product water. So that's what's going on inside your water maker when it's turned off. It's just the natural movement of the sodium and chloride ions through the membrane into your product water side, and that's why your product water is a little bit salty. But it's not just the salt molecules that want to move. When you pickle your unit and store your unit, those same chemical compounds that are in your pickling reagent, they will slowly move across the membrane while it's sitting as well. Even if they're being rejected at a 99% flow rate or a migration rate, the longer it sits, the more concentrations want to equalize on each side of the membrane. So that's what's going on. If you have other water maker technical questions you've always wondered about and would like to get some answers on, I'm always available at rich@cruiserservices.com, and I'd be happy to make a video about it. So everyone have a great day and enjoy your water maker.